Hi! In this video, I will be sharing with you Amazon GuardDuty, which is a managed security threat detection service from AWS. As seeing is believing, I will run a demo to showcase how can you use this service to detect a simulated attack from the internet. I will also walk you through the process from alarm triggered, security analysis, all the way to identifying the potential attackers and remediating the risks. So now let's start. Now let's talk about why we need the GuardDuty at the first place. And let's assume you are a security engineer responsible for the threat detection in AWS environment owned by your company. Essentially, you would look into various security-related data sources to identify any potential threats. So this includes AWS Guard CloudTrail, which captured all the AWS API call related activities within your account. And similarly, you will look into the VPC flow logs for network activity trackings, RDS log activities for database user login, and also Kubernetes audit log if you're using containerized applications on AWS. And of course, you might look into other types of the logs that are available from other AWS native services, depending on what you're trying to achieve. And once you've collected the relevant data, you would use the tools of choice to analyze those data. And then here comes some couple of the challenges that we need to solve. Firstly, it is the signal to noise ratios, which is hard to manage. As a security professional, you want the threat data, but it's difficult for you to manage the solutions and the policies to filter out those noise. Secondly, it'll be the complexity of the solutions to build and also run it. Hence, most of the companies are facing skill shortage issues. Last but not least is the cost. It comes from not only the security solution licensing service cost, but also the operation cost associated with that. And as a result, the company got an unhappy face. And as we can see, a lot of challenges were caused by the complexity nature of the self-service and the managed solutions. Well, that's why Amazon GuardDuty can come in to help. As a managed threat detection service, you don't have to manage the underlying solutions and you can focus on the threat detections. What you need to do is to activate the GuardDuty via the AWS console. Then it will start to look into the data type as we just mentioned, which includes the S3, container workload, and IAM users, roles, etc. Behind the scene, it uses machine learning and pattern matching to identify the potential attack and the risks. So to trigger the findings with the detection information, then you, as a security engineer, you can proceed to take action on it. Before the demo, let's take a look at a common attack model. Amazon GuardDuty attacker lifecycle, and this basically showcases the process for an attacker trying to compromise our resource and create impact. So generally, they would start with reconnaissance to explore the system vulnerability. One of the common attacks that they would take is to find the open SSH port, which can be used for the brute force attack. And then in the establish a foothold stage, the attacker would ensure they maintain the continued control. So they might start to install the RAT or the remote access tool on your system to maintain the continuous control. And then when it comes to the escalate privilege stage, the temperature continues to rise up. Attackers might start to exfiltrate the data over the DNS, which allows a large amount of the unstructured data to be sent between the attacker and the victim. Furthermore, in the internal reconnaissance stage, the attacker would explore the victim's environment to gain a better understanding. And this is where the attackers start to probe the API with the temporary credentials. Last but not least is attackers would try to maintain the persistence for this attack by compromising the account. So basically, this is just a quick run through for the attacker lifecycle. While understanding this is really key when we use the GuardDuty for the threat detection and execute the remediation accordingly. Now let's take a look at the demo environment. There are two EC2 instances acting as attacker and victim accordingly. The malicious host on the left-hand side with this public IP address, it represents the attacker which we pretend to be running on the internet. And the elastic IP address of the malicious host is actually in a custom thread list in the GuardDuty. The other instance, named the compromised instance, which we've shown here with this public IP address, this instance actually acting as the web server that was lifted and shifted into the AWS recently by your company. Although the company policy is that only the key-based authentication should be used for SSH, at some point, the password authentication for SSH was enabled on the compromised instance here. This misconfiguration is identified in the inspector scan that is triggered from the GuardDuty finding. The malicious host performed a brute force SSH password attack against the compromised instance, and this brute force attack is designed to be successful. The brute force attack was successful, and the attacker was able to log in to the compromised instance. And then the compromised instance will also have a cron job that continuously pings the malicious host to generate the GuardDuty finding based on the custom thread list. And then the API calls that generated by the API findings come from the malicious host. The calls actually use the temporary credentials from the IAM role for the EC2 running on the malicious host. The GuardDuty findings are generated because the EIP attached to the malicious host is in a custom thread list. The temporary credentials are issued by the IAM, which does not flag them as far as it is concerned, and they are still perfectly valid. So now we just jump into our demo environment. The key function that we want to demo today is the findings under the GuardDuty service page. And within the findings, you can see all these potential risks that's been identified. Because our demo environment has been running for a couple hours, so we can see now there are around 79 findings that's been identified. So the first thing I want to look into is the finding types. So let's use the filter to do findings. And finding type, we can specify one of the finding type. In this case, will be unauthorized access. So we can see a couple of them. And if we click into one of it, we can see this is the description list. Let me just zoom in this part. Hopefully you can see this part clearly. So basically, this part in the description, it tells us what does these findings mean. So it means API update instance information was invoked from an IP address, this IP address on the custom thread list. So what that means is that GuardDuty has identified a API call that's been initiated from the thread list IP address that we provided to GuardDuty. And if we scroll down a little bit, we can see some other overall informations. The first part is it tells us the regions and account ID, which account being impacted. Apparently, this is our account environment. And also there is a resource ID, and this resource seems to be a EC2 instance. If we click into that, it can lead us to this EC2 page. And basically, it is the EC2 instance that we run to pretend to be the malicious host, we can see the name is a red team, right? If we switch back, and then we can see the resource affected. In this case, would be a username. So this is a IAM user because the malicious host has been attacking our victim host, and then to get the IAM role, and with this role, it will be able to retrieve the IAM user information and then to conduct this API calls. So this is the general process. And if we scroll down, there will be some other information from the instance details. I would skip this part for now because this is related to the malicious host information. And this part also similarly, it tells us the IAM instance profile used by this malicious host and also the instance tags. What I want you to focus on is the actions. So in the action section, we can see this was a AWS API call action, which means that this is a data plane action rather than a management plane. So it's likely caused by a malicious user, which has detect and retrieve our IAM roles information like the temporary credential, and then to conduct this API calls. And also, we can notice the actor. This is the actor public IP address, and this is exactly the IP address that's been listed in the thread IP list in the GuardDuty. And if we keep scroll down, basically there are some general information that's been shown up here. So for the first step, we identify the malicious host information and the IP address that's been related to this finding. Well, similar to the first finding, now we can look into the other findings. So we can see this exclamation mark here, which means this is a high severity findings. So let's look into that. And the first thing again, let's look into the descriptions. This name of the finding is the cryptocurrency EC2 Bitcoin tool. And if we look into the description, it says EC2 instance. This instance is querying a domain name that is associated with the Bitcoin related activities. So apparently this doesn't seem to be a normal activity and is very likely to be caused by a malicious user. And in this case, actually it was our malicious host running on the EC2 instance. So on the right hand side, you can see similar information that's been shown up here in the GuardDuty. And we can find the resource ID actually pointing to the EC2 instance running the malicious software. And if we scroll down a bit, the thing that I want to highlight here is that actually is in the action section. And this one, compared with the first one, this one is actually the DNS request. So potentially this data source was actually caused or captured by the VPC flow log and has been identified by the GuardDuty. Well, the third findings I want to showcase is this one, the reconnaissance EC2 port scan finding. If we click into it and to read through the description, it shows the EC2 instance. This instance ID is performing outbound port scans against the remote host 10.0037. So if we look into that, couple similar information as we saw before with potential attackers information here. And the key thing I want to highlight here is if we look into the actions, this is the action type is the network connections, and as mentioned before, this is an outbound attack against our victim host. And this is a local IP which actually pointing to the malicious host. The key information that underneath the target section was a private IP address. So basically this IP address was associated with our victim instance, which we will look into shortly. So with the information we have, we are about to locate the EC2 instance that's associated with these findings. Then if we look into the findings, we can see the EC2 instance ID here. Actually, this is the performer or the actor of the findings. So if we switch to the EC2 instance page, do a search, we can see there is a instance name red team that's with this ID. And then switch back, we can see the target. Copy the target IP over, and then we can search it. We can actually see the target IP here, which is a private IP, was associated with the instance, which is named the team target. And we just stopped these two instances for the highest security control. And of course, we have other options to do. For example, we can put this instance into the quarantined security group to stop the further attack from them. And one thing to note here is that the time, if we look into the time for the last seen findings, it was actually caused or created 23 minutes ago. It's quite recent. And because now we have stopped the instance and we can expect no more new relevant security findings will be created within the GuardDuty. For now, we have seen the demo to showcase how can we use the GuardDuty to detect attacks against our EC2 instance, and how can we take action to remediate those risks. In the next couple sessions, we are continuing to use the GuardDuty to identify the potential attacks against our S3 bucket as well as the IAM users, and how can we remediate those risks. So please stay tuned for now. I hope you enjoyed this session, and if you find it useful, please give it a like, and you're welcome to subscribe to my channel. Thank you, and bye for now.